Steven, we're live.
We're
Wow.
live. All right. Welcome, everyone. I'm Steven. This is Mateo from 3DQ, and today we've got something special for you.
You're going to be testing QuinlyVision yourself, and we're going to be commenting on it. Um, and this is going to be really fun because this is the first time anyone's ever been able to use it for themselves.
Yeah, so you're going to be able to actually use any photo and send it to QuinlyVision and see, and QuinlyVision will tell you what it thinks of that photo. And you'll be able to do that now, like
So, yeah,
right during the stream, and we'll be here reacting to whatever happens.
yeah,
So, really excited for this one.
I'm very nervous.
You're nervous. I'm excited.
Yeah. It's something we've been working on for a very long time, so it's really exciting to be able to let all of you try it. Um, so yeah, maybe we should say, what is QuinlyVision?
Yeah, what is this thing we've been working on?
Yeah, so QuinlyVision is a machine vision model that can watch your prints and look out for failures. So it kind of replaces that need to constantly monitor and worry about prints you might have running at home.
So no need to stare at your print the entire time.
Right, exactly. But it's a lot more than that too, because compared to other detection software, QuinlyVision has the ability to tell what types of failures are occurring. It can be a lot smarter, so you can set up automatic responses to different types of failures as well.
Yeah, so like with stringing, you get maybe a temperature reduction if it notices stringing,
Yeah,
and then maybe reduce temperature by 5 degrees, and then if it fixes that, then it just continues with that temperature for the rest of the print.
yeah. So
Yeah.
it's going to be very powerful. Hopefully, reduce a lot of headache running your printers. But the thing that we're trying out today is just a very small portion of QuinlyVision. We have 3 fails active, and you'll be able to send pictures to it and see whether it detects the fails or not.
Yes, we're calling this QuinlyVision Mini.
Yeah, kind of inspired by, I don't know if any of you guys have looked at Dali Mini or any of those like interactive web AIs. It's like a mini version of QuinlyVision. Um, so it's a small sliver of what it can do,
Mhm.
and it's almost like something that you could run locally on a Pi. Actually, it's like that's how minified it's been.
So it's
So
very lightweight.
yeah, super lightweight, super quick. So you can just spam images at it, basically.
So this is lightweight enough that it could possibly be doing the local recognition
Yeah,
without having to go through like cloud stuff.
yeah, and we'll get into more of that later. So I think we probably want to, you know, show people how they can interact with it.
Yeah. So we've got a Discord bot set up.
Yeah,
So actually, on our Discord server, the automated 3D printing community server, there's a link in the description, and if you join, then you'll be able to access this channel called QuinlyVision Sign Up. And it's really quick. You just have to click a button, and then you can submit any image you want to QuinlyVision and see what the AI thinks of it.
yeah, and there are some guidelines here too, which we can talk about and show. But all you have to do to get access to it is you just hit this, try it out. You'll get a special role that lets you post in this channel, and then in this channel you can just, um, you know, what we'll be doing is we'll be copying images from Google, and you can just paste them in, and the bot will download the image and then process it and then spit back the result. And so we've got scores up here, and we're going to keep track of how many accurate results it gets and see who wins.
Yeah. So what happens if it gets it right? Who gets the point?
I'll get the point.
You get the point.
Yeah, I've been working on this for so long.
Yeah. Okay. And so if it gets it wrong, then I get the point because
Steven doesn't want it to work.
I'm the devil's advocate.
Yeah,
I don't want this stuff to
you
work.
don't want it to work.
And so what do we get when we win?
The last Red Bull in the office.
So we got donated a whole 24 pack of Red Bulls by a mystery person,
Mystery person.
and I, but also other people drank 23 of them. So we got one more, and me and Mateo are gonna be fighting for the last one here.
Okay, so I've just given access everyone who has, if you click this button, try it out. Okay, people are already spamming stuff. So we should mention it's only going to detect stringing, warping, and nozzle blobs. So if you send a picture of something like spaghetti, it's actually going to omit that because we're
Mhm.
really interested in testing these finer, I guess, finer failure modes. Because
Okay.
spaghetti is the thing with spaghetti is that's usually like when the print is completely gone. You want to be
Yeah.
able to QuinlyVision wants to be able to catch it earlier so that you can actually fix stuff during the print.
Yeah,
Like,
so an early fail detection before it turns into spaghetti.
yeah, exactly. So it looks like people are already posting stuff, which is exciting. We should also pull up the chat. Okay, let's see who's in chat. We've got Jack, Matea. Oh, we got Polymaker in. That's very
Hey,
exciting too.
Polymaker, nice to see you.
Polymaker, as a filament manufacturer, I'm sure is seeing a lot of 3D print fails happen
Yeah.
everywhere. Um, and so, yeah, so make sure to read the guidelines for submitting the image as well. Because we had to minify it so much, it kind of reduces the how general it is.
Hmm.
So getting a side-on picture that's relatively good resolution is going to be really important. Okay, let's see what our scoring is. So Jack, okay, so this is one for me. This one it missed, so that's one for you.
It's upside down.
It's actually upside down. uh, this one I wouldn't consider stringing. I would consider it bad overhang. So I would give that a point to
That
you.
almost looks like it was a warping test.
This is a warping test. You're right.
Or like a yeah, like a warping and overhang test,
Yeah,
which it didn't seem to do too well on.
and it missed the nozzle blob. Although this is a very strange angle.
Jack knows that this won't work.
Did you try it?
uh, he just knew it wouldn't work.
Yeah.
He said in chat it wouldn't work.
All
So
right.
he knows.
He knows. He knows. Okay, so we gotta update our scores real quick. What is that? That's 2-2, I think.
2-2.
All right. Let's edit this.
So one of the fun things is, yeah, you can browse Google for images of print fails. But if you have any prints of your own, you can also take a picture. Like, I don't know if you have a box of failed prints. A lot of people do. I do. But if you have a box of failed prints and any of them have like stringing or warping, what's the other one? Nozzle blob. I guess you can't really do that. But you can take pictures of your failed prints and then send them to QuinlyVision. It doesn't just have to be Google images.
So this one has no fails. This is interesting. They're doing false positive detection. So there actually is some stringing here, but it shouldn't be detecting the whole thing. So that's going to be interesting to see. Maybe we need a larger data set of Voronoi models with holes in them. And then here it seems to have caught like the little indent as warping. So one of the interesting things that's important to know is when you're grabbing photos like this from Google to try and get like the whole uh, model as it would appear on a print bed. So usually actually photos from a little bit further out do better as well than super zoomed in photos.
So you want the whole print in view,
Yeah,
and you want to have a view of the surface that it's sitting on
yeah,
as well.
yeah. So like something like this would probably be too zoomed in. And like a camera wouldn't really look like this when it's working on your printer.
Hmm.
But then something like like this would probably be better. Although this is a very low resolution image. So let's try maybe something like this could work. Let's see what it does.
Now, we got a question from Polymaker. How good is QuinlyVision at recognizing moisture issues, especially bad surface quality? So I think that was actually the calibration cubes that you posted before. Um, but that's actually not part of the detections that are working right now. If it detects bad surface quality, it'll categorize it as under or over extrusion. And if it's moisture filament in your filament, it'll probably end up looking like over extrusion because it'll expand the filament, so it kind of looks bubbly. Um, but right now, I don't think there's a specific moisture detection uh, failure type. Um, but it does detect bad surface quality. So I guess, yeah, like under extrusion can cause bad surface quality, like small pits. Over extrusion can cause kind of the like bulging outside and really buff surface. So I would
Yeah.
think, yeah, moisture would probably detect it as one of those two right now.
Hmm. I think, Jack, I think you're submitting images from a mobile phone, which is why it's flipping it. So, again, to reiterate, best is side on or top lower, um, because that'll give you the best detection because it's actually a realistic angle. If you're already taking a photo from underneath the nozzle, that's not actually going to occur
You're never gonna have a
with a
camera on your
webcam.
build plate,
Yeah.
right?
Yeah, so something like this is actually is like very zoomed in, and this actually zit detection would probably catch this, and then this would probably be considered over extrusion. Um, but right now, yeah, we're testing warping and stringing and nozzle blob. So the other types are deactivated for this test. Um, People are submitting so many images, it's going to be hard to keep track of everything that's going on.
So does this work? So this is like a queue system, right? Like if you like the first person to submit an image, it'll go into a queue and then it will do one by one kind of thing.
Yeah.
Right.
So this one's interesting in that the stringing has been isolated. Because when it catches stringing towards, actually, this is a perfect example of something you might see from a webcam because you're looking at the part of the print that's recently happened.
Yeah.
So because QuinlyVision is optimized for catching things quickly, it actually does better when the part isn't fully complete. And you'll notice with some of the detections, it'll bias towards the top of the part
Yeah.
because that's the part you're most interested in detecting because that's where the most recent issue would have occurred. So something like this, where you've got the nozzle and just the top of the part printed, it'll do really well with images like this. And this is something like maybe not quite so zoomed in, but this is something you would see uh, as you're printing from a webcam pointed at the print.
And I imagine this would also pick up no extrusion, like if all the failure modes were turned on, it would detect that the nozzle is too far away from the part.
Yeah, it would probably get under extrusion because there's exposed infill, um, and then no extrusion because there's a nozzle that's not touching the part. But what it did catch with only stringing enabled was the strings that are happening up top here.
Cool. So it's a point for you, I'd say.
Right,
We have a
right.
lot of points
I
to
don't
be
think we
giving.
can count the points. It's kind of crazy.
It is a lot. Maybe
Yeah.
if someone in chat can
Tally
tell
up the
us
points.
how many points, because there's a lot of images to go through.
So here's another one where actually a very interesting thing I discovered a few days ago. It detects warping so early that if you give it an image of like a part that's already completely warped off,
Yeah.
it won't catch that.
Right. It just looks for a thin part that's
It'll
warping.
catch for the start of a warp, which is the most critical part. Like you don't want to catch a warp when it's too late.
Yeah.
You want to catch it as soon as it happens. So it actually does much better with these slight warpings than with the with like
Because when it's
I
like
had an
super
example
banana
earlier.
shaped,
Yeah,
right,
the
it won't
super
work.
banana shaped, it won't catch that.
But it'll actually detect the really slight part where it still touches the
Yeah,
bed. I know the one you're talking about, I think.
yeah. So this one it didn't catch. This one would be interesting to run back and see why it missed it.
Is that the first one that has no fails?
No, there was another one where it didn't catch it, which is
Oh
this
yeah.
one. But this
So that's not that wouldn't be any of our fails.
and it's the image is too low resolution as well to resolve anything. But there's nothing active that would catch this one. So this would be a good test for when we activate pour first layer detection and also over and under extrusion detection. So one of the interesting things, um, and I think this is something we'll test as a trio of detections, is pour first layer, over extrusion, and under extrusion. Because if you detect pour first layer and over extrusion, those two pieces of information tell you the nozzle is too low to your bed.
Yeah.
So you could possibly in QuinlyVision create a script that moves the nozzle away if it's detecting something
So
like
like
that.
baby steps your nozzle up by a little bit.
Yeah,
So that would be automatic first layer calibration to some extent.
yeah, to some extent.
Yeah.
Or even just telling you like, hey, your first layers are getting closer than they usually were. You might want to calibrate your printer.
Mm-hmm.
Um,
Check your Z offset.
yeah.
Even.
So that's going to be like a later test that we're going to do.
I imagine I'd be more comfortable having the nozzle automatically move higher than automatically move lower, just as a safety measure.
Nicholas, you submitted the image that was specifically the bad example.
Well, I wonder if you probably just wanted to see what would happen, right?
Yeah, it's a good test. It did actually pull something out of it, which is interesting.
Did it think it warped halfway up or something?
No, it got the warping. Um,
Oh yeah.
but it's like way too zoomed in. It doesn't have context for the whole object.
Mm. Yeah, because this object could be really big or really small. Oh, they've started doing the.
Yeah.
There was some point in the stream where I knew people would realize that they can submit any image, and I think we found it.
Yeah. The warping the on the banana. I mean, it
That's
looks
exactly
like
what warping looks like.
It does look like warping. Yeah, so stuff where the object is cut off or too far in or too late into the print, into the fail, it actually won't catch those things. We need to submit things that are happening quick and early.
So this nozzle blob actually is a good example of that. Like this with QuinlyVision, a nozzle blob would never get this big.
Yeah.
Because it actually detects, like you have to kind of be able to see around the hot end a little bit to like see the spaghetti little bits that are like touching the nozzle.
Yeah. This is also not an optimal vantage point, but I guess, the thing is, again, this is so minified. Like you're basically interacting directly with the model. There's no logic or filtering on top of it. So you're seeing what the model sees without any sort of intelligence behind it. What we'll be working on adding is, so one thing that's really important to QuinlyVision is like sequences of events.
So a video.
So a video basically, or even a time lapse.
Yeah.
So as soon as it has information about what has changed, rather than just looking at a snapshot in isolation, it can do a lot more with that.
Mm-hmm.
And something that I'm really excited about with this, and also with the launch of the time lapses built into Quinly, is having people upload time lapses directly into this and test their time lapses with this, because then you get that you get to track how stuff happens over time, and then it does much better.
Right.
For example, warping is a very slow process, and it relies on the model knowing the object was once flat and then it changed.
Yeah.
So just by relying on a single image alone, it's pretty cool that it can actually detect it in a lot of cases, but there's so much more accuracy that comes from knowing the context of, just like you would when you inspect your printer. If you're noticing stringing, you might check your temperatures and be like, oh, I'm printing way too hot for this material.
Yeah.
The same kind of logic will be built into QuinlyVision, where it will look at stuff like your G-code file or your current printing temperatures, what material is you're printing your file in, so that it knows, can be more confident about what it's seeing.
Mm-hmm.
And if it sees something happening over time, that's even better, because just like how you might check in on a print from time to time to see what's going on with it, if it's printing well or not, it does that, but continually for the entire like hours long duration of your print. So it's like, you can think about it, the more like the fully fledged model basically is modeled after how an operator understands their print, how you would look at your print when diagnosing stuff.
Because this is what QuinlyVision replaces. It replaces the human that's supposed to be watching the print or monitoring it.
So even stuff like this, it's like the warping is already really far in and it's missing the edges of the print. So it doesn't have context that this is actually a printed object.
Because the whole edge is actually warped.
Yeah.
But it would actually look at the point at which some of the edges are still connected and some of them are warping off. We should see chat. There's probably been some messages that we should actually probably figure out how to make it bigger.
Oh yeah, weird.
Hello, we got a new person. Lutz 408.
Let's say.
Let's say.
Yeah, how do we view more chat?
Yeah, it's very small for some reason today.
Well, should we try some more images? Or let's see what people submitted. So there's stringing. It's got that.
It's interesting actually. It picks up the actual strings higher up in the print, and then when it gets really low, it almost looks maybe like something else.
Well, it's biased towards the more recent parts of the print.
That's true.
why.
Yeah,
So
right.
it'll start ignoring stuff. Because presumably, if you've let the print get to this point, you might have suggested it to ignore. So there's a feature that we're building into QuinlyVision where it can pause the print as soon as it sees something, and then you can select whether to cancel the print or to ignore and continue. And that's why it's biased towards focusing on the more recent parts of the print.
Because presumably it would have actually, like, either if there's fails that it ignored, there's no point in trying to fix the ones that were way down at the bottom of the print. It'd be easier to fix the fails that are right near the top where it's actually still printing.
Yeah, like if you got stringing at the bottom of the print and then you stop getting stringing later, you don't want to start messing around with your temperatures
Yeah,
because
fair enough.
you're not getting stringing anymore.
Yeah, makes sense.
So this is actually an interesting example that Nicholas posted, just calibration cubes. But you can see like in this mini version where if it's cut off, it doesn't catch it, but where it's fully visible, like the edge of the part is fully visible, it detects it.
I guess it's probably also worth noting that it does crop the photos to some extent.
Yeah, it crops them to be 720p. So if you can supply a photo at 720p or larger, it'll shrink it down to that size. If you supply a photo that's too small, it'll try and expand it, but there might not be enough resolution to work with there.
So I actually tried submitting like a really long photo earlier today, and it just took the middle chunk
Yeah,
of
it just chops it.
Yeah.
But what's interesting, which is a limitation of this bot, but isn't a limitation of the full setup, is because the full setup can take 3 images together in quick succession or look at a series of images, it can kind of combine those and get much more detail than it would have from a single isolated image.
So is it turning those 3 images into one image, or is it looking at all 3 and then comparing?
It's kind of like considering 3 images. Like if I sent you a picture of a print, you can tell me, okay, here's something might be going wrong with it. But then if I send you a picture of that print at 3 angles, you'd be able to tell me a lot more about what's going on.
Right. So I guess QuinlyVision, it would probably look at something and say, okay, this 2 out of 3 of these have warping, therefore it's more likely that it's warping, rather than if it's 1 out of 3, then maybe we ignore it.
Yeah, or like exactly. It might also be able to focus down on where in the part the warping is happening better. Right. Would QV watch for warping on top of a raft or support? That is a good question.
Oh yeah, we should actually get if anyone has an image of stuff warping off of a raft. I think it's maybe less likely for stuff to warp off of a raft, but I've never really printed on rafts, so I don't know.
I think that it would still catch it. I don't know why it wouldn't. As long as the raft is a flat raft, it would catch it as warping.
Yeah, and I think if the raft was warping, then it would definitely still catch it as warping.
Yeah. I'm just trying to. Okay, we got the chat up. That's awesome.
Yeah, Polymaker says, "Can QuinlyVision settle the debate around the root cause of warping?" And this is one of the controversial topics in 3D printing right now.
Oh, is it?
Yeah, because no one really knows what goes on. Apparently, the common idea of it being thermal expansion is not 100% correct, and there's, what is it called? Viscoelastic effects that can also cause warping.
Nicholas, you gotta send higher resolution photos. These are tiny.
Oh, yeah, if you can see the individual pixels from a... Yeah, because 720p is what we're asking for, but it's always interesting. Well, that still worked.
Kind of.
It didn't pick up the right
It's
side.
it'll start to get confused because this is purely running on feature detect. Like it's looking for features because all it has is one photo to
Right.
work from, rather than a video. So low res photos, it's got a hard time with. Yeah, so it's getting the warping. This one, it actually detected the. I would probably consider this spaghetti and not stringing.
Yeah, that's spaghetti. Who's
What is
that?
this?
Who is that?
Warping.
You're warping, Mateo.
Apparently, I'm warping. Yeah, so this would be classified as a poor first layer, which is why none of the things would activate for this one. Um, but this is going to be an interesting use case to test when we activate those, or well, when we try poor first layer. Um, the reason we segregated it in QuinlyVision was intentional. It's so that um, it doesn't give you the wrong impression of what's happening. So you want if it's
Mhm.
on the first layer, you want to know all about that first layer. You wouldn't really consider strings on the first layer stringing. You wouldn't
Yeah,
fix it in the same way. So first layer issues will be classified as a poor first layer.
it's interesting that we've got some, I guess, good prints that people are sending too. Oh, and Jack just sent a raft print too, so we can. It's a good raft print from what it looks like.
Might catch this stuff though. Let's see.
Other than I guess the uneven layers,
No, it was
it thinks it's
it
good.
it passed.
Yeah, I mean a good thing to do is just send pictures of good prints and see what QuinlyVision thinks.
This one would be interesting to run through over extrusion because it's kind of what Nicholas was talking about with poor surface texture.
Yeah,
You're almost getting over extrusion on the sides. It kind of looks like it, although I don't think it is.
it's probably just bad
And then,
mechanics of the
yeah,
printer.
and then under extrusion on the top. I wonder if that would detect correctly. So one of the things that we'll be doing with these tests, and the reason you should get people to hop in and try it out, is we'll be cycling the types of failures that are active, um, and as well as adding more of that advanced logic I was talking about into the bot itself. So you can kind of think of it this way, like the QuinlyVision bot is the image that's downloaded from the internet and the bot just detecting it, and then there's a little piece in between that grayscales it and does a little bit of like brightness adjustment.
Hmm.
So it's very, very simple in order to be able to run fast. Like since we've started the stream, we've already gotten a few hundred, like 100 images submitted.
Yeah,
The full model is far more complicated
so
than
it's like a
that.
chain of things that happen.
There's like a whole image processing chain. Um, Depending on the type of fail you're looking for, there will be different chains of things that the images get processed through.
Also,
With
like logic as well
Yeah,
built
because
in.
like with some stuff you have to consider time. With some stuff you can just use image recognition,
Hmm.
like more basic image recognition. With some stuff you need to crop the image in certain ways. Depends
Yeah,
what you're detecting. So it's far more complicated and advanced, which is why I mean we can show you some of the videos that we've gotten running the full model with the whole pipeline.
hmm
Um,
yeah. Let's put up some of the examples.
yeah, like here's one that um, was the full.
So this is all the fails enabled
Yeah,
as a time lapse.
and yeah, so what's key here is there's time context.
Yeah, so it can
um,
see change over time.
yeah, so like immediately in these first couple of frames the warping starts to expand, like from this to this it basically immediately catches it because something is changed right away.
Yeah,
And that's so important as a print operator to catch stuff this early on because already at this point you would get a warning, and you could even set it up to pause and be like, there's been a sudden change in the amount of warping that's detected. So if we keep going,
And it can see
Actually,
on the right side as that work. Did it develop over time
yeah,
slowly?
it does. So you can see it,
Yeah, so it's kind of good right now, and then it
it gets wider over time.
interesting.
So you can see how much more accuracy time series images provide.
Yeah,
Um,
that's cool to see it slowly.
and now here's one that's really interesting that actually wouldn't work with just images. It needs video to work,
Right.
um, which is detach.
Yeah.
So detach is when your print comes off the build plate, and I think all of us have experienced something like this.
Yes.
This one actually relies on stuff changing.
Right, because if you say like my print is right here, is it supposed to be there? Or maybe it's supposed to be here
Yeah, you don't
or
have any
here.
context for
You
it.
have to see some relative motion between print being here and then it's there
Mhm.
in order to know if it's detached or not.
Also, there's also other like it's a very complicated system, but the end result that we're trying to get to is something that gives you very easy to interpret results and very simple results. Um, you don't want to have to go back and play through time lapse footage to understand what happened if QuinlyVision can tell you, um, for example, like let's say you come to your printer and you see this, you're like, well, what do I need to fix? The
What caused this
Yeah,
fail?
what caused this fail?
It's actually like a lot of people would say, oh, that's a layer shift, tighten your belts. That's not the problem.
Yeah, imagine you take this off your printer and put it on a table and showed someone that.
Yeah,
Without the context of it being printed, they would say, oh, you got a layer shift because they wouldn't have seen warping develop into a detach. And that's the kind of really important thing we're trying to do with QuinlyVision is have it monitor that for you, warn you when it happens, but also at the end of the print, give you like a root cause analysis.
good question from Polymaker.
Yeah, so Polymaker asks, what is the goal of QB? Fail detection means a fail happens. So does that mean QB's goal is to save filament and avoid damaging your printer? What fails can be 100% recovered? So I think the goal of QuinlyVision is fail prevention, to catch stuff before it becomes a fail like this. You want to catch stuff here, basically.
And I think a good thing to make a differentiation between is defects versus fails.
Yeah.
So defects are things that can be recovered from, or things that don't catastrophically fail a print, like stringing or under extrusion or over extrusion. Sometimes warping can be fixed mid-print. You like tape down the brim, for example. Whereas fails are like spaghetti or a nozzle blob or a full nozzle clog.
Mm-hmm.
So I think the fact that we can detect the defects, like if you detect a single string, then we'll know that there's a likelihood for more strings to occur. So we can do something about that. If we detect under extrusion just a little bit, we can say, okay, maybe we can fix this increased temperature or something. And so instead of the whole print being under extruded, you just have a little bit of it.
Yeah, and it depends on your use case too. I know a lot of prop makers will, I mean, I've seen it where sometimes they're printing like a 48-hour print, and this is a huge print. It costs a lot of material, but for them, it's the machine time and hitting the deadlines for producing the props or producing the models,
Mhm.
where they might have like partway through, it starts under extruding. Um, you don't really want to restart that whole 48-hour print. And there are a lot of tools that are out there for recovery. But if QuinlyVision can stop that as soon as it sees something, so you can go and address whatever the issue is on your printer, um, and then continue that print. In that particular use case, that minor defect is easy to paint over or finish over,
Yeah.
and a lot of people do so it depends. I guess it depends on your tolerance and it depends on your use case. Um, I know for me, if I'm printing something that I'm going to paint over, I would love to have something that can recover small parts of under extrusion. Even though
Yeah.
it's a defect in the final print, there's post processing, and I haven't just lost like 24 hours of printing and 24 hours worth of filament. With stuff like stringing, if you repair it, stringing is a really great example because if you repair it partway through the print, um, that just means less cleanup for you. And it doesn't, when stringing happens, it doesn't affect the integrity of the model. So that's one of those like defects that I think detecting benefits pretty much everyone, because you don't want to restart a print due to stringing, but also the print is not necessarily bad because it has stringing.
Hmm.
So if you can minimize stringing, that print is saved. You have a tiny bit of cleanup, but way less than if you had to restart the print or um, let it finish and then clean up all the strings.
And another thing to point out is once it makes that change to your stringing and say it fixes your stringing by increasing the temperature, you can just save that as your new G code with
Yeah.
a different temperature offset. So you don't have to reslice the part. You can just use that G code file. I would say also another thing, another like big reason for why QuinlyVision is actually it makes automated 3D printing better. Um, because with the ability to clear the bed automatically, we can actually. So imagine a part fails at like midnight. A normal 3D printer, you'd have to wait until the morning, clean the whole thing up, and start the next print. Whereas with QuinlyVision, if we detect the fail at midnight, we can just knock the failed print off using the vapor bed. So the vapor bed cools down, nozzle can push the part off because it releases, and then we can start the next print in the queue. So if you're running like a print farm, um, you don't have to have that whole 12-hour downtime period. And say you had a customer's order for the next day, um, you would have like 9 out of 10 parts printed instead of zero, right? So that's just the benefit of having some automation and failure detection working together. Um, and that's kind of like the vision, the QuinlyVision vision. I had to say it
Yeah.
once. But like that the two power like the power of automation and the power of automated supervision kind of like multiply with each other to make something that's much greater than the sum of each.
So Nicholas had another good comment here. Even defect detection means a defect is there. So how would this be usable for a print service, for example? Does it depend on how tolerant the business is on a defective print? So stuff like stringing is considered a defect, but it doesn't compromise. If you need like a perfect part, it doesn't compromise the integrity of the part. You can still use a part that has a bit of stringing that was then fixed later in the part. And that tolerance changes for everyone, which is also why in the QuinlyVision app, you'll be able to adjust tolerance for each type of fail and adjust like the decision making, um, just like you would. Like you would basically tailor it to your use case where with stringing, maybe pause it and I can make some adjustments and continue the print. If I get severe warping, just cancel it altogether because I need tolerances to be perfect. If I get
Yeah.
under extrusion, cancel it, make an adjustment to the next iteration so the next iteration is perfect. And it takes all of that troubleshooting out of the equation for you because it's kind of funny that the people who usually need like engineering grade
Get like
um
transition going.
sure who need like engineering grade perfect prints are also the people who don't usually like print as their main thing. I've
Yeah.
noticed like if you're doing a prints as that have to fit within a larger assembly or something like that, um, the type of troubleshooting is like figuring out what needs to be changed in your next iteration is a really big pain, and that's what QuinlyVision can help with as well. Because if it's saying, it got stringing resulted in under extrusion, means your temperature is probably too high.
Yeah.
Um, then the farm operator at that facility, whether it's a print service or whether it's someone just trying to get a good print for a larger assembly, doesn't have to Google any of these problems anymore. And even if they have to start a new print, they can start it so much faster because there's the step of troubleshooting has been removed for them.
You can do a few more of these prints. I know there's been a bunch more before.
Yeah,
Or since
interesting
we
how
were.
much more challenging it is with static images. Yeah, it definitely is more challenging with static photos.
Well, this is why I guess also the failure rate or the misinformation rate online is so high because it's actually quite hard for humans to give proper feedback based on print images.
Yeah, and also like one of the things is oh we let's scroll this way back here. It's actually operating with like 10 times less information than it would usually be given. So here, this one is pretty clear, like from a single image you can tell. And actually, this image is nice too because you can see the whole part,
It's fully in frame, touching the bed.
and it's at a realistic angle as well.
Yeah.
This might
It's
be a
a
good one too.
warping.
Yeah, so you can see it actually does far better with like actual in progress print images.
So it's actually like detach as well. It looks like.
Yeah, it has been detached. That's correct.
Mm-hmm.
I like how it picks up the little hairs on the bed. So that's something also that um the higher logic will start filtering out that kind of stuff. Like if it's away from the rest of the print, then it might not actually matter too much.
Well, that's part of what our model detector is also used for, right?
Yeah. This one's interesting though. I wonder what this would be considered, if this would be spaghetti or poor overhang.
It looks kind of like poor overhang, actually. Oh,
Yeah.
it's a Quinly. The first. I don't know what this is though.
What's this filament?
This is filament coming out the wrong area.
Yeah, this is the filament has exploded out of the printer.
Do we have a no Bowden tube connected fail type?
I don't think so. Don't actually, it might catch this as, I don't
Too
know.
thick to be stringing, but maybe it will pick it up because it's
I would probably pick
thin.
this up as spaghetti.
Yeah, like it probably is. It might be too smooth for spaghetti. You never know.
That's why you should come back and try when we switch which ones are active.
So
And
like next week we'll do a different set.
make sure to invite people too. Like if you think like from other servers or stuff, people can try it out. So see something like this would be actually it's extremely low resolution.
Is that under extrusion?
This would be probably under extrusion.
Yeah, it looks kind of like a
Actually, we have
some sort of ridge or bulge or
we have an
opposite
example.
of that.
We have an example of a very similar under extrusion being caught, but video. It was video again. Under extrusion. So who do you think is winning right now?
Yeah, can we have some general vibes in chat for like who's
It's
me or
like
Mateo?
pretty even right now.
Because there's way too many images for us to keep track ourselves.
I think it's doing quite well for the no context, just images from Google.
Yeah, so I guess images that follow the guidelines, I think you're probably winning.
Yeah,
For all images, I think I'm definitely winning.
yeah,
But I don't think we need to count every image as acceptable.
yeah. I don't.
But let's see, chat, what do you think? Who's using your best judgment, who do you think is doing better? Mateo for QuinlyVision getting things correct, or me for QuinlyVision getting things wrong?
Within the parameters we set.
Within the rules that we've set
Yeah,
up.
yeah. There's a reason that I put those rules. It's because it's if you knew how squished this model was, you would be impressed.
It's like, haha, QuinlyVision thinks a banana is warping. It's a
It's
banana.
like working with like 5 pixels versus pieces of video, small pieces, or even time series stuff. Um, let's find we do have video of an under extrusion that looks really similar to this.
Was this the thinker?
Yeah. Do you know what it was called? Oh, here.
Your transition so they can see too.
Yeah, I just wanted to make sure it's the right. So this one is like this one has video that it worked with. And it was catching these lines as under extrusion. This is actually a very old version of the model, which is why it's quite unstable. But one of the interesting things is, and you'll see this with analyzing individual images, is some frames they might actually miss it for whatever reason, whether it's motion blur or just noise. Which is why it's so important to have more context around it.
Yeah, because you need like an average over time,
Yeah,
really,
exactly.
in order to get good results from any sort of failure detection.
Yeah. All right, let's check. Oh my God, there's been so many chats. We apologize for missing these. We'll go back through it. Is it possible? So Al was saying it's possible to recover from warping, and Nicholas is questioning it.
So I'm gonna say yes. I've recovered from warping before by taping down my brim and reducing the bed temperature. Um, it's not a recover. You can't fix it, but it prevents it from getting worse. Um, so if you don't mind a little bit of warping on the bottom of your print, you can save it. But if you need your parts to be perfectly flat, then you might not be able to save it.
Um, Maybe we should tell people how to join if they want. So in the description of the video, there's a link to our server, which is all about automated 3D printing. And once you're in the server, if you go to QuinlyVision sign up, um, read this because there are limitations to the bot. It's a Discord bot. It's not a fully fledged piece of software. It's not the same thing we use for the videos. Read this, click try it out, and you'll get permission to post photos in this channel. And yeah, just try photos from Google or from wherever you want. Actually, an interesting fact too is none of our data set in this bot model uses Google Images. So
yeah.
every image that you find on Google is actually completely brand new to QuinlyVision. So it's a really, really good test of the model itself because you could pick any of these images and it will have never seen them before.
So we've only trained QuinlyVision on images that we've taken on in-house.
This version is for the bot is only on in-house images. So no, we didn't scrape images or anything. Because it's a good test of how does this generalize. Like as a human, you can look at an example photo, and humans are very good at generalizing things. So you can look at a photo in a manual or in a tutorial, and you can be like, hey, I saw this thing before. But it's very, very hard for computers. So one of the things that you guys get to help test is how does QuinlyVision, the model, generalize to all sorts of crazy photos coming from the internet. And you can see like all of these photos are cropped differently, they're different colors, they're taken with different types of cameras.
Some of them have really sharp reflections on the bed, like glass, and others have no reflections. That's a pretty important point. Some of them are on a Quinly, so your print's going to be tilted.
Yeah, there's like a lot of crazy stuff. The resolutions are all different and crazy as well. So that's something.
I like this one. This is really nice stringing.
Okay.
Jack, that's one of your fancy shapes, isn't it? I know you do this kind of stuff now.
But yeah, so if you want to join, just hit the try it out button, and then you'll be able to post photos in here.
Desmos, yeah. Well, it's not a fail, so that's good.
Yeah. I wonder if we activated spaghetti, if it would actually try and catch this stuff. Trying to make a CAD model that says it's stringing.
I wonder if a spider, can someone send a spider web? I want to see if a spider web
we can Google a spider web.
Oh, yeah, we can do that. Yeah. Because that would be kind of like a very stringy looking image. Like probably like a one with really fine web. Oh, that's interesting. That's like a wallpaper.
Like this, maybe?
Maybe, I guess that's too, got the water droplets. I'm thinking like the really fine, silky.
Maybe cobweb.
Oh yeah, cobweb would be a good one.
Oh, like this?
Sure, yeah, let's try that.
Let's try. Okay. Didn't get it. It's too smart. What did? Okay, let's try it.
What was the one before? It was oh, the whole thing was stringing.
Read this, fix your string.
This is a really fun print. I've never done it, but I'm assuming you can just, I can do this on purpose. You just turn off retraction and you over extrude, I'm guessing.
So this is too dense to be stringing, I think.
Yeah, so it's actually picking out like single strings that it can find, kind of.
Yeah. I think if this was a video, like of it moving, it would just not even detect it.
Yeah.
It would just be like, what the heck is this?
Is there some, do the strings have to be parallel to each other? Because it looks like it's kind of almost, the boxes are vertical.
No, not really. What I've noticed is It does really good when the stringing is attaching between 2 points of the print.
Oh yeah, yeah. Which is
And
you like that's kind of how stringing always is.
yeah,
But if it's visible in the frame, I guess is what's important, right?
yeah. So it does like it will do better with horizontal stringing. Um, I don't know. Let's try like, but maybe this is kind of it's cut off. Here, let's try this one.
I like the ones where there's kind of a comparison. If you can get an image with a good model and then a bad model in the same image, that's a really nice way to sort of give QuinlyVision two, one that's good, one that's bad, and it will ideally tell you that the bad one is bad and the good one is good.
Yeah, so it does really accurately with when the stringing is joining 2 parts of the print. Here's a good example too, although it might
Yeah.
be low res. Oh, the anticipation. Okay, yeah, I got it too.
Nice.
Which is funny because none of our stringing data set actually uses these stringing tests.
Yeah.
There are 0 images of stringing in that.
Yeah, I think the closest one was an Eiffel Tower,
Yeah,
and we had like a pyramid as well that was pretty stringy.
that one's not included in the data set.
Oh, we're not using that one.
No, I haven't put those in. So it's funny, it's like I wonder if we could even just recognize stringing tests because it's like so good at catching those.
Yeah, so that's the thing. Some people are like, "Oh, is it only going to work on benchies because the most popular prints are benchies?" Like, no, we've trained this on completely random models from Thingiverse and like things that are very uncommon. We're not just running stringing tests and we're not just running refraction towers to find these fails.
Okay, let's take some time. I'll leave this to auto scroll. Let's take some time to catch up on chat. 'Cause there's been a lot of chat as well, and this has been exciting.
Yeah.
Um, so Zombie Hedgehog, yeah, definitely join the Discord and try it for yourself.
Those guys mods on Polymaker
Oh, cool.
Discord,
Okay,
pretty
okay,
sure.
awesome. Um, so there's some discussion about salvaging the prints that come from warping. I think if you're printing on a raft, I've seen warping happen on the raft itself and not the rest of the print.
Yeah.
And those types of things you can salvage.
Yeah, and I actually find reducing bed temperature can fix warping. If it happens just in the very first layer, you can, or second layer, you can reduce bed temperature. That can sometimes save the print.
Let's see this comment.
Stephen wins, yes, because no one followed the rules.
Yeah, unfortunate.
Yeah, well, with the section of people that are following the rules, I think we're actually getting mainly Mateo ahead here.
Yeah. But it's cool because you get to test the bounds for yourself. And as we open over time, as you come back and we open or switch the types of detection that are available, you'll be able to see like what I like to do is test images that I've tried before. Like for example, this image is a good example of spaghetti, and we don't really want it to be detecting stringing. And so once we activate spaghetti, is it going to detect it? It's like a good comparison to do between iterations of the model.
Well, it looks like it's just detecting a tiny little bit of that model as well. So it's ignoring most of it because it's
Yeah.
actually spaghetti, not stringing.
It could do also with how it's cropped.
We should actually do a bot one day when it's just spaghetti and stringing enabled, and then we could have the title be like spaghetti or stringing.
Yeah, we could do something like every week or every other week switch. Well, I was thinking every other week we switch the type of fails that are active. And a stringing versus spaghetti would be really fun, I think.
Because that's one where I think a lot of people might say, "Oh, how can you differentiate between the two? They both kind of look the same."
Zombie Hedgehog says, I don't have any bad prints. Find some on Google.
Oh, you're the only one in the world I think
Yeah.
that doesn't have any bad prints.
That's a good problem to have. I wouldn't be sad about that. Okay, they've caught us up.
I like Polymaker's most recent. Can you detect warping?
Can you detect warping?
I don't think it detected this warping.
No. There is actually a whole strategy for creating these where you try and generate false positives and it can learn from that. This is gonna be interesting. Will it detect this as warping? Or...
Could be warping
I
because
don't think
there's
it
a
should be,
shadow underneath
but
it.
it's so uniform. It's not.
It might just be an overhang.
Ah, I got this one. This one here. It caught it as warping. So this would be where you would need like more advanced logic that would say, this is so little warping and none of the other parts, similar parts of the print warped. It's probably a false positive.
Yeah, and it's also a very small area. I
Mhm.
I know like small areas can be important like in Zits, but if it's a small area in relation to the rest of the model, maybe it doesn't matter so much.
Posted, okay, so Zombie Hedgehog posted his most recent TPU print.
That's a TPU print. That's pretty good.
This is extremely impressive for a TPU print. Wow. That's crazy actually for a TPU print. Let's see if
On
it
a
detected
direct drive,
anything.
I'm guessing. Actually,
Zombie
yeah, what printer
two
was this
meter
on?
Bowden. Yeah, it'd be
Because I don't
something.
know, Ender. I don't think an Ender can print TPU that clean with a Bowden,
No way. Even this part's
unless it's
not
like super hard TPU, like 108 or something.
why did it crop it like this?
That's super weird.
I guess QuinlyVision it's like when you're staring at your printer and you're like, what's going on here?
Yeah.
It's doing the same thing. But it did get a little bit of the stringing. Although I would personally I would classify this as a poor overhang. But it could be that it is and it's just not active. Okay.
This is a square. Hey, that's interesting that it found out that it's warping though.
Maybe it thinks it's like a cross section of a print.
Well, because it's looking at it from the edge on, kind of,
Yeah.
but it's not on a surface either. So
This is an interesting problem. And this is something that specifically won't happen with the full version of QuinlyVision because it will learn to ignore the printer itself.
mm,
And so you can get it. This is a very interesting example of that. Again, just like you would as an operator, you're not going to look at your printer and think it's part of their print.
yeah.
The same thing, we have to teach QuinlyVision to ignore parts of the printer. Um, so this is actually a really cool example.
So does it take a photo of the bed before print starts and kind of
Yeah,
uses
you
that?
can teach it to ignore things that are static.
Mm. Oh, so I think Nicholas is trying to create, like in Paint or something, warping. Like he's trying to simulate what these things would look like in Paint. It's interesting. I don't think we've actually tried this, like having completely like hand-drawn veils and seeing if it picks it up.
You did so. Zombie Hedgehog has been printing these TPU prints with a direct drive on their Ender 3.
Direct drive Ender 3, that makes more sense. Because the Ender 3 can print beautiful stuff. It just, with TPU, I think you need a direct drive.
So interesting why it's turning on. It might, you know what? It might be the way I implemented resizing. I might have just done it wrong.
Could also be like, photos have these metadata bits in them that sometimes give orientation information.
Yeah.
And I think sometimes phones have different uh, metadata, exit data, I think it's called.
Okay, so this guy is Polyterra PLA.
Oh yeah, I like Polyterra.
Okay, Al is trying his hand. Yeah, we're only testing warping, stringing, and nozzle blobs.
Yeah.
Um,
Oh, here's a good question. If you go to that the green Benji up there, what would this fail be? Because I think Nicholas was trying that specific fail using the hand-drawn image.
mhm.
So this is probably stringing, but it's not stringing. It's due to oozing during travel moves, but it's not
I think it
gonna look like strings.
it gets counted as stringing still because you often find it um, in like near stringing,
Yeah.
those little branches.
Well, I guess yeah, because if it identifies that stringing usually correlates with this stuff, then it might identify it as stringing.
This is cropped though. I don't know if it'll detect it properly. Oh, yeah, I
Huh.
got it.
Interesting. I
So
love these little alien branches
the
that come out.
tendrils,
Yeah.
yeah, it is interesting.
It's cool to see all these people in chat. If you guys have any other friends that you know who've been using like the Dali Mini, because I know that's kind of gone viral recently, and they're also into 3D printing. Invite them onto our Discord and get them to send their 3D prints in, because I've been having a lot of fun on our own personal QuinlyVision. I got access to this bot before you guys, and I've just been having fun throwing images at it. Like one of the ones was when the spaghetti detection was enabled, I threw photos of spaghetti at it until it got that
Until I got it.
until it said it was spaghetti, and that was just the best.
I think we got one of my dog.
Yeah, because if you don't know, Mateo's dog is got dreadlocks. What's it
He
called?
looks like spaghetti.
What breed is your dog?
Pooley.
Pooley. Yes. And his name is Carbon.
He looks like this.
I don't know how you can even see like with those dreadlocks.
It's like it shields their eyes from the sun.
A natural sunglasses, but it also shields their eyes from everything.
Yeah, he's walked into walls sometimes.
Aw.
I got this.
Oh, cool. So the stick is stringing
And then the stick on the ground is warping.
because it's on the ground.
I
And you
guess
can.
so. Yeah, you want to keep it within the domain of 3D printing. Oh, yeah, Jack. This is my dog that Jack has a photo of.
Oh,
Saved.
I wonder if the tiles are going to be stringing because they're very
It's
sharp
such a.
lines. Oh, maybe.
Oh,
Yeah, a little bit.
it's coming out of the object, I guess.
Yeah. That's interesting. So I guess, yeah, stringing does kind of have to be connected to something, otherwise it's not stringing.
Hold on, I'll find one of the detections we got yesterday of my dog. But I'll play. Why don't you talk about nozzle blob recovery? Because this is another one, maybe
Sure.
a bit to Polymaker's point about detecting defects or repair, even self-repairing the printer before it happens. I think that's really interesting to a lot of people. Like, how do I get the printer to be smart enough to fix itself?
Yeah. Yeah, so this you play it first.
Yeah.
Oh yeah, okay. So this is an experiment that I did a few months ago. Essentially I caused a nozzle blob on purpose and I tried to just see what I could do to make the printer automatically recover from the nozzle blob. So by the time QuinlyVision detects a nozzle blob, it's not big enough for it to be completely engulfing the hot end, but it will be like pushing plastic into the nozzle and the thermistor and the heater. So my first try, this was my first try. It was essentially just to heat up the nozzle to normal printing temperature and just extrude a ton of filament as much as possible, while making sure that the nozzle is away from the print bed. Because a lot of what makes nozzle blobs happen is because when you're pushing filament into the bed, there's nowhere for it to go except for up. But if there's a lot of space underneath, then you get gravity helping you out. But this is one of the auto recovery features that we were thinking maybe could be possible in QuinlyVision. So instead of having a nozzle blob stuck to your cold hot end when you come back to your printer, what you'll instead have is, your printer paused, the nozzle blob fallen off, and maybe you just have a few strings you need to clear off of your hot end with a brush before you can go and print again. I know print farms commonly get nozzle blobs because they're not able to watch first layers all the time. And it's often easier to simply like take off the entire hot end, replace it with a good one. And maybe if you have time, you can repair the old hot end. Sometimes just throw it away because it's like $10, $20 to get a new hot end. But that's just nozzle blobs, right? There's other kinds of ways that we can do automatic recovery. So in the case of like a layer shift, for example, we can cool the bed down if it's a vapor, knock the part off, and start the print again. And then if it layer shifts again, maybe we just knock the part off and go to the next thing in the queue. So we could have a maximum number of retries per print. And if it fails after 2 retries, go to the next thing in the queue. And this kind of stuff, these automatic recoveries are only possible with Quinly automation. So how have you been doing with getting these
I found him.
carbon? Oh, perfect.
Although I had the sensitivity had to be cranked way up in order to get it to detect.
It's beautiful.
Yeah, it's just funny.
This reminds me of if any of you guys have watched Silicon Valley, there was a app that some guy made called Hot Dog or Not Hot Dog,
Yeah.
and all it could do is tell hot dogs or not hot dogs. So this would be funny to do spaghetti or not spaghetti.
Yeah. Um, Actually, one of the things Al mentioned, he completely missed his work photo. I think for this photo in particular, you'd probably want it to, well, first off, it ended up cropping the top, so make sure it's in the middle, and also put it like have a lot of surface around it as well. Um, because again, because it's getting a single shot of context, it doesn't actually know where the printer is or where the printer would be.
Hmm.
So it's important to have it on like a very flat surface without too much else going on. Especially this where the top of the object is cut off, it can start considering it to be the background. Actually, it might be interesting. Oh, we'll make our mic louder. Thank you for telling us.
Well, this is a good point from Polymaker. So theoretically, QuinlyVision will never detect a nozzle blob. There must be another failure detection before a nozzle blob. And that's a very good point because nozzle blobs don't just happen. There's always a bad first layer or like a detached print that turns into a nozzle blob. Um, but one of the things that we've done with QuinlyVision is we've made it able to detect the causes of the failures, but then also the failures. So just in case it didn't catch the bad first layer, it can still detect the nozzle blob because of course you want your printer to be protected from nozzle blobs.
Yeah.
We don't just want to be detecting defects and we don't just want to be detecting failures. It's important to detect both.
Actually, there are cases where it would catch it as a nozzle blob first, where the vantage point of the camera can't see under the nozzle all the time.
Oh yeah, okay.
So like if you have like a really small print, for example,
Yeah.
where the hot end is usually covering it, that's when you would miss that first layer issue, and it would get it as soon as the nozzle blob got like kind of
That's
larger.
interesting. Okay. So I know a lot of printers have like a big fan shroud around the hot end, makes it hard to see the nozzle.
Yeah.
So that would be, yeah, I guess a good reason why a nozzle blob would occur without anything being detected before it.
Yeah, I would try more like top down, or not top down necessarily, but like more from where you'd be looking at like the middle of a printer plate. Um, just so that it ignores some of that background stuff. One of the things I had to do for the bot, because it doesn't know what your printer looks like, it has to be heavily biased towards the center as well. Hopefully the mic is a bit better now. Let us know.
Yeah, it looks like we're getting close into the range of it being like red. If I'm very loud, it gets close, but yeah. Because if it gets into the red zone, then it doesn't sound good.
Okay, let's see what's going on.
So we have a fully cropped image. Oh, this is probably one of those images that's going to get cropped.
Let me try something.
Very wide.
It did kind of get it. Let's try this.
Yeah, because if it's too wide in one dimension, it'll crop it to be closer to a square. This. Oh, we got Mateo in paint here.
Yeah.
Gonna do some sketching or something.
Oh, what is it?
Maintain aspect ratio. Click that.
Thank you.
Paint master here, right? If you guys don't know, I like some of the Quinly manuals. I try to put it in paint.
Don't say that.
Oh, that's fine. It's my favorite tool. It's the best tool.
Let's
MS Paint.
let's try this. But you can see how much of a difference it not being as cut off makes. All right, let's try this.
Okay, so we doctored an image to make it more.
This doesn't seem like the right aspect ratio though.
No, it's like two squares next to each other. Oh, he got more
got
paint to
it.
work.
He fooled it.
Interesting.
Yeah, it still got cut off. I guess we can just make it taller. We can look at some, why don't we look at some videos of the first layer? And
Sure.
yeah, for anyone just joining us now, click the link in the description. You can go to our Discord server and try out a very minified version of QuinlyVision. Go to QuinlyVision sign up, hit the try it out button, and then you'll get access to this channel. And yeah, post some photos, and then we'll look at some other videos, and then we can come back to this too.
Cool. So we're looking at first layer defects getting picked up by
Yeah,
QuinlyVision.
let's look at those. There actually is a really good example, I think.
Yeah, we had a well when I made the poor first layer video. Oh wow.
Yeah, we're going a bit too crazy with the image processing, I think.
So when I made the first layer fail video, QuinlyVision explained poor first layer. I got some images and videos of like first layers that are too far, first layers that are too close, and I guess first layers that are peeling. And then I think there's a folder that we have with all those fails in our drive.
Yeah, let's go to that. I already see some interesting stuff being posted, so I'm excited.
Here, I'll type it.
Sure.
Here, click on poor first layer people. And it's probably that. Yeah, so there's over extrusion, under extrusion. Yeah, so this is the rough stuff that was created by a nozzle being too close. So I guess you won't actually get, well, you can get nozzle blobs because of this, but I don't think it's the main reason why nozzle blobs happen. I'd say it's more likely if your print's too far away from the bed to the point where it detaches. But this is where I guess it'll say if you get poor first layer and over extrusion, then your nozzle's too close, and we could automatically raise Z or baby step it to make it a better first layer.
Mm-hmm. So I think this is the one where it's just for first layer. Yeah, and this has none of the smoothing that we usually put on it too. So these are like just raw videos. So you can see even here, it's highlighting these little blobs as over extrusion, which could be, even if you're looking at it through a webcam, you know, if you're busy and you have 40 printers you have to monitor, it can be really easy to miss these small things. But QuinlyVision will be there 24/7 to find this type of thing.
So it does look like this is too close to the bed.
Yeah, I would say marginally too close to the bed.
Especially in the top, you can see it probably a bit better. Is there a string? Yeah, there's a string too. That's a good catch by the stringing detector.
And then there's this really interesting one, which I know, not this one. Oh yeah, okay. This one does detect a nozzle blob for a second, but this is an example of where a nozzle blob, or like where the first layer is hidden by the nozzle, and so it doesn't really start to see it until it's more of a nozzle blob. So you can see here, it's where it was getting dragged around by the nozzle. It was like, okay, there might be a nozzle blob or a detach here because it's moving, and it's moving with the nozzle. So that's why it's a little bit indecisive. It doesn't know whether it's a detach or a nozzle blob at some point.
That's cool how it like picked it up and moved it around and it instantly became a detach.
Yeah. So it sees it's moving relative to everything else. And then when it picks it up, it's like, okay, this is for sure a detach. Like that is very clearly detached.
Yeah.
And then here, where the nozzle is almost entirely covering it, it's like there might be a nozzle blob because there's like motion that shouldn't be there, and it's moving with the nozzle.
Yeah.
Time is the most important factor. It can make the AI 1,000 times better. Definitely. Like as soon as you have, and it's like with people too, as soon as you have more information, it kind of collapses really quickly onto higher certainty.
Because if you watch a whole print, you will be able to tell what happened. Because a lot of
Yeah.
people ask, why did my print fail? Because they weren't watching it when it failed.
Yeah.
You know, like a lot of that can help just by having a full time lapse or a full, even with QuinlyVision, we'll be able to have a time like a recording, a video recording of 30 seconds before the fail, during the fail, and after the fail, where you can like actually you personally can look and see what went wrong. Because sometimes you actually just want to see it for yourself.
You have that animation, right? Is it this one?
Which one?
The one that shows the graph going.
Oh, I think it's five. That might be 5.api.
Yeah. So, if I was staring at the whole duration of my 4 hour print, I could tell you a lot about it and a lot about how to fix any sort of defect. And I would be able to stop any sort of defect before it turned into a fail. And so QuinlyVision replaces the need for doing that. I mean, it might sound ridiculous to watch a 4 hour print from
Mm-hmm.
beginning to end, but a lot of people watch the first 20 minutes of their first layer. And a lot of people also will like hang around their printer to make sure everything is going good. And that still adds up to be a ton of time.
Well, sometimes I like if I'm printing something and I'm cooking dinner, I'll be like just looking at my print every minute or so just to make sure it's going, especially if it's doing a first layer. So here is our UI concept for QuinlyVision, showing change over time. So this is why, yeah, as Polymaker said, time um, is the most important factor because now you can track change over time in terms of like the fail confidence, the fail percentage, what kinds of fails are there at different times. Um, in this example, you can see that warping is the first thing to occur. So the root cause of this fail is warping. Um, the detach probably wouldn't have happened if there was no warping. And the layer shift only exists because it detached. So a lot of these things are like a chain of events that you have to trace back to one thing. If you can't determine which one happened first, then you don't know what to do to fix your print.
Exactly. And I know, like, to most of us watching, this is kind of at this point second nature, but it can get overwhelming as soon as you start having to do more prints or you're under time pressure or you have more printers in general. Um, there's a lot of kind of, it takes a lot of mental processing to constantly be dealing with these things. Um, if you work in a team ever, like, how do you communicate what 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 I started during one shift and failed in another shift? That person then has to communicate back to me, here's what happened, here's how you need to fix the print. Whereas with something like this, I can just go and scrub through and see exactly what the problem was and even get suggested corrections right away.
Mm-hmm.
Um, yeah, so that's going to be really, really cool. Okay, let's go back to Discord. Got some more submissions.
So we got a bit of warping on the corners there.
Yeah, tiny
And
bit of
some
warping.
curling as well, looks like on the rear end of those boxes.
Okay, so it got some of the warping. Um, and actually it's funny, it detected the lines on the print bed as stringing. So again, if this was a video, it would have seen these lines are present before the print, so we can ignore them. Um, just like Al was probably like, oh, those are always there. In my brain, I'll ignore that. The print bed just looks like that.
Yeah.
You can teach the same thing to a computer. Okay.
So what is this? It looks like a pile of.
Installation.
Oh yeah, a pile of.
Noodles, maybe.
Looks like an elevator. Oh no, this is a print. Okay.
Is this? Oh, it's an SLA print. Maybe.
Yeah, SLA. Or I have no idea what a failed SLA print actually looks like, but
Oh my gosh, Nick.
Polymaker, your images are getting so much better every time. It's like
It's
you're
going
turning into
crazy.
three-dimensional.
Oh, this is interesting.
Thinks the hand is warping.
It thinks this is warping too because there's a
It actually
gap.
does look like it's warping. Like that looks like what warping looks like.
So for something like this, the sensitivity is clearly too high for this model.
But
Um,
also, I wouldn't fault it for detecting the fail as warping because that's what warping looks like.
this,
It just happens to be a dinosaur. Yeah.
yeah. I guess it's not really sitting flat even all the way to here.
Yeah.
Although this would probably be classified as poor bridging.
Yeah.
Um, this is so interesting. So this would be a poor first layer, which isn't active right now.
Yeah, and I think this would also just be a poor first layer. Bit
There
of
is a lifting here. I'm curious if it, because there are a lot of tiny, tiny, tiny warps in the data set. I wonder if it does consider this to be this curve to be lifting. I don't know that it actually is lifting.
I think, well, as humans, I think I could say that might be lifting,
I don't
but
know.
I don't think I get the shadow to know if it's actually lifting or not. I think we'd have to see the shadow.
And this is just at the bottom of the crop. So the stringing it seems to be really well. Actually, stringing is one of the first ones that I worked on and is right now in the best shape.
Okay.
Um, but yeah, there's
And the
also
spaghetti works pretty well too. I would
spaghetti works
imagine.
pretty well. Yeah, that spaghetti is very easy to detect because it's so obvious.
Yeah.
But smaller defects, I think stringing is a good one. Um, yeah, it's going to be interesting looking at this stuff later and seeing like because warping is interesting. It's a bit of like a risky one to try because it is one of those time dependent um things.
Yeah.
So it is cool to see like even with a single snapshot, it's able to pick it up um in some cases. Are you gathering data on the link between G code, material, and failure? At a point, you might be able to prevent failure instead of detecting them. Run the G code in the AI and guess the potential failures. Um, yes, so the full QuinlyVision is a host. So you'll run your prints through it, and it will consider things like what material is being printed. It will look at things in the G code and compare it to what's currently happening to understand like you know for example in G code you can tell whether there's a part that's bridging and you might want to turn up the sensitivity on bridging related defects for that part of the print or you know when the first layer is happening so you can detect stuff for the first layer. So yeah, absolutely, that's one of those things that we would want to collect that information between the relationship between that stuff to make the detection more accurate and then to also suggest more accurate fixes. And it might come to a point at someday where we can look at a G code and just say you're printing PLA, G code with these settings are known to cause stringing with this type of PLA, so you might want to turn your temperatures down even before anything starts printing.
Yeah, or it could just detect that you're not you have retraction disabled.
Yeah, that would be
You
really
know,
cool
like your retraction distance is way too low, or
for
it's
TPU. Or it's like,
yeah, or you're not retracting at all during this print. Is this a phase mode print? And maybe it's phase mode print, but like, if it's not a phase mode print, then why aren't you retracting? I think another a good use case for G code analysis is when there's no extrusion happening, because when nothing's coming out of the nozzle, we want to know, is it a travel move? Because if it's a travel move, then you don't want anything coming out the nozzle.
yeah,
But if it's a printing move and nothing is coming out the nozzle, then there's a clogged nozzle where the
right.
filaments run out. And so you can look at the G code, is it G0 or is it G1? And most slicers will tell you it's G1 if it's printing, G0 if it's traveling. So another reason why G code analysis is going to be useful for QuinlyVision.
Yeah, it helps improve the accuracy and response time, but it also will help make predictions in the future as well.
Yeah, so there's both.
How would you trick the AI for stringing? We cannot trick it. Well, The thing with the AIs is
Good.
they're pretty opaque.
Maybe I think the thin lines is what it is good at detecting.
Yeah.
Like if it's really sharp and really thin, like even 1 pixel thin, and there doesn't need to be tons of contrast, I think.
Mhm. Why don't we just hook up a rotary encoder to track precise filament movement? I think this would be an amazing feature that should be built into printers. But what we're trying to do with QuinlyVision is more of a solution that's accessible to everyone. So you don't have to buy a printer that has a specific feature when all you can do is plug a camera in, um, and start using it on any printer. Because I think a lot of people agree stuff like the Bamboo Labs with their first layer LiDAR scanning is extremely impressive, but wouldn't it be nice to have those types of features available to the printers you already own, like the Ender 3s or the Prussias that you already have, without having to set up super custom hardware? So
Yeah.
that's where we see QuinlyVision fitting in is for people who want access to those really nice features, um, that just makes printing a whole lot easier, and it can make any printer smarter. You don't have to buy a smart printer. You can make your printer smarter. And I think that's really important.
Yeah, and I think like another thing is a webcam can be 14 different sensors, right? We detect 14 different fails. It can
Yeah.
be a substitute for 14 different sensors, right? And sometimes there's not even a stringing sensor, right? So, um, yes, there's like a filament runout detector, there's a filament encoder wheel, there's like crash detection, stepper motor drivers, and these are all detecting one specific type of fail quite well. But a webcam can detect all kinds of fails pretty well.
Yeah.
And that's really good for a lot of people because a lot of people don't want to have like tons of mods and upgrades on their printer. They just want stuff that works.
Yeah, it's kind of
So,
like a 14 in one sensor, or
yeah,
even more, because depending on what is detected, you have like subcategories of issue, because
yeah,
of this time component that we consider. Um, yeah, like even if you had a rotary encoder on your printer, well, actually a rotary encoder, you could make it so it tells you if you're under extruding or over extruding.
yeah.
But with something like crash detection, it doesn't tell you what caused that crash. But with something like QuinlyVision and crash detection, so like integrating with the sensors on the printer, you can see like, oh, the print started warping and that caused a crash. It's a warping
Hmm.
issue. Or the
Yeah,
print was over extruding and it caused the nozzle to have too much, material in the way. That caused a skip. Fix your over extrusion. So just having sensors isolated is not very useful. But what you can do with this whole feedback loop that QuinlyVision provides is it gives context to what you're seeing in your sensors, and it tells you how to fix, um, these issues that are being brought up by your sensor. Because you could
yeah.
also have like motors skipping and QuinlyVision detects nothing, then that could be an electronics issue. So you could even have like anti detection.
Right. So like almost as a failsafe,
Yeah,
if your
there's nothing
sensors
wrong.
on your printer aren't working, at least QuinlyVision's detecting it too.
Yeah,
There's that.
yeah. There's nothing wrong with the print. It must be something with the hardware. That kind of stuff you can do. Can QB help calibrate each step's flow? That is a good question. I think it can.
Probably not. I would say
I
you
wouldn't.
can't calibrate E steps, but maybe you could adjust flow if you can see the top surfaces are over extruding.
I,
I
I
would
think
want
you
this to
could
be
give
manual.
general guidance. I think you could give guidance like,
Yeah, I think guidance is the way.
yeah, especially if you have prints that work in one filament and then don't work in another filament with the same settings. Then you know it's a flow issue.
Yeah.
That's how I would. So it could give you guidance. It could be like, okay, TPU, you need way higher flow because you just use the same settings as PLA and it's under extruding. So that kind of thing, it could give you guidance. I don't think it could give you like a number.
Yeah, that's it. It would give you a qualitative answer, not a quantitative answer.
Yeah.
So, yeah, would it detect bad top layers? It should. It would detect it as under extrusion, and
Yeah.
it would say you need to increase flow rate or you need to decrease E steps, but it won't be able to tell you by how much.
Yeah, and part of this project too is we could work on like developing stuff over time, like where we read into G code and have certain detection take into context what part of the G code you're on. Um, Definitely like or switch different types of detection on, but depending on where in the G code file it is. This is all stuff that we want to beta um, when we launch the QuinlyVision when we launch a Kickstarter. That's those types of ideas and features is stuff we're going to collect feedback on during with the group of beta testers and also have them test to see whether it's something that's feasible. So like this for example is a really great idea um, where we could see how effective it could be for calibrating each steps.
Yeah, Zombie Hedgehog has a good point. It would be cool to train the bot on a specific test print and then have it monitor as you print it. And yeah, it would be really nice to have like a calibration print that's got maybe retraction and temperature and stringing and all these different things built in, um, which maybe also allows you to set your sensitivities for QuinlyVision.
Mm-hmm.
So like, it'll intentionally cause a certain level of stringing, and then the amount of stringing that you're okay with, you can tell it, okay, ignore it until it gets this bad, or something like
Yeah,
that.
yeah, that's a really that would be a really good use case because you could say, put your camera here, print this, and then get just really precise readings
Yeah.
of what's happening. Um,
And there's probably like optimal camera positioning for various print fails, I would imagine.
yeah,
Like if you need to see the nozzle clearly, for example, then you'd have to have the camera like mounted on the x-axis so that as it moves up, then the camera moves with the nozzle, so you can always look at the nozzle. Um, and that would be really good for detecting like no extrusion issue or like maybe stringing. But then maybe if you want like to catch larger fails like spaghetti or maybe if you have a really big print, you need to have your camera farther away from the printer. So different camera angles might you might be able to come up with like optimal camera angles for specific kinds of prints.
possibly. Although it's our job to make it as lenient as possible, as general as possible. But
Yeah,
yeah, if you can't see the nozzle, you can't tell whether it's extruding or not until much later.
yeah.
Thanks, Nicholas. Yeah, it's going to be exciting. It's going to be interesting seeing these tests. So definitely, the more people are trying it out, the more we'll learn about it too. So I definitely recommend people try it. I don't know that we actually did a everyone ping for this stream. So maybe we should do that and see what people submit this evening.
Yeah. Well, should we keep it open for a bit longer?
The bot will stay online from now on.
Interesting. Okay.
Yeah, it's fine to stay online. I might take it offline from time to time to update it
Okay.
or to switch what's running, but the bot will remain online, I think.
Okay. So I think what we'll probably do then is during live streams we'll launch new failure detections where people
Yeah, we can try that.
do that. Cool.
Okay.
So this was fun.
Yeah.
We have a question. We still need to decide who gets the Red Bull.
Right. Who won?
Who won? So if QuinlyVision got it right most of the time, Mateo wins. If QuinlyVision didn't get it right most of the time, I win.
Are we
So
going with these rules?
going by the rules that we've
Okay.
set, yeah. So no like random images of dogs
Okay.
and things. Uh,
We didn't really count well. We only counted 4.
yeah, because it was so many
There's
to
like
go through.
there were about 100 images submitted.
Yeah.
So who wins? Hmm. Hmm.
I want to say generally, like in some cases it didn't get it, but I think in a lot of cases it did. Polymaker says Mateo gets the Red Bull.
That's one vote for me.
And to be fair, I actually drank more than half of the Red Bulls. So
And I've never had a Red Bull before.
you've never had a Red Bull? Oh my God. Now it's
I don't do
now we're
super well.
biasing the audience and making
Well, I don't do well with caffeine, so
uh, caffeine's great.
yeah, maybe.
Actually, although I've started having decaf coffee because stuff didn't like the effects of caffeine either, but it can be really good if in small enough doses.
Oh yeah, I guess I didn't tell Steph this. QV will stay up. So for anyone coming to watch this later, or if you have any friends that might not have made it to the stream, send them to the QuinlyVision sign up channel and have them try it themselves. Very curious to see what people get.
And also post your results on like different Discords and Reddit and stuff. I've been seeing AI images showing up everywhere now on like from this Dolly Mini and the actual good Dolly, the Dolly 2. But yeah, a lot of people are into AI right now, so I think it's a good time to be doing stuff with QuinlyVision.
Polymaker says that I win because they couldn't fool the stringing, but they did trick it with warping.
Yeah, see that's a tiny little string, but that's the stuff that's actually good at picking up. Like a blurry, thin line.
Except for here.
Well, that's just a thin line. It's not that blurry, but yeah.
I guess it's cropped. That's the thing. I have to figure out how to maybe just detect the part is cropped. Send a wider shot.
Crop detection. Scroll fast.
You have no idea. Like, I think it did pretty well for random images from the internet that it hasn't seen. Like
Yeah.
it absolutely there are no images in the current data set that are not internal. I don't know.
Yeah.
I think it's doing pretty well.
Kevin says it's a draw. Can't do much with that. Maybe you have to split the Red Bull tomorrow.
Okay. Sure.
It's a bit. You can't say it's
I'll
a
try
draw.
it. I'll try it.
Mateo's gonna try Red Bull.
taste it.
That's the win for today. Mateo tries Red Bull.
If I don't like it, you can have the rest.
Okay, how about that? I'll take it. Yeah, sure.
That's a good compromise.
It's a compromise. So Mateo gets first dibs.
I think we're pretty even, actually.
Oh, it picked up stringing on the spaghetti. That's funny. How did we miss this? We missed this
We
somehow.
missed.
Because it's the cheese. I think the cheese looks like stringing.
Yeah, because it wouldn't have picked the spaghetti up. It's way.
It's too noodly.
The resolution is low though.
So when the resolution's low, it thinks spaghetti is stringing.
It just for this bot, the image processing is a lot simpler, so that it runs fast. Uh, yeah, it's the actual like the full scale model is more complicated.
Yeah. Well, it's almost like Dolly Mini. If you've been tracking the AI, there's someone kind of like made their own version of Dolly and called it Dolly Mini. It's not as good as Dolly 2, but they kind of both do the same thing. Dolly Mini is available to the public, and Dolly 2 is not. So, because it would be huge. You can't do that stuff in a browser.
Yeah.
So thanks for submitting all these images. I look forward to seeing how this develops over the next few weeks.
Yeah, it's gonna be fun.
Stay tuned on our live streams and subscribe to the channel so you know when our live streams are coming. If you want to be notified when they're coming, you can hit the bell, and yeah, you can share this to other people. If anyone that you know is interested in AI, 3D printing, both, link them to us, link them to our Discord, and tell them to join our QuinlyVision trial, because I had a lot of fun with it. I think you guys have had a lot of fun with it, and it's only going to get better from here.
There's something addictive about spamming images.
Yeah, this you can actually spam images.
Yeah.
And,
It's really fun.
yeah.
And I think when we get the time lapse submission working, or short videos, it's going to be even more interesting to watch.
Yeah, definitely.
Yeah, so hopefully this was like a cool demo that you guys found fun, and definitely share it around. Thanks to everyone for their support on this. Um, yeah, definitely. I want to get more people testing it. It's pretty fun to see where the bounds are of what's working.
What can AI do?
Yeah, what can this highly compressed AI do or not do? Um, because yeah, we do want to have a portion of it running locally if possible.
Yeah.
So this is a really good test. Cool. All right. Well, thanks everyone. We'll see you next week. Check back often. Maybe there will be different fails active. Um, if you get that role, you'll also get pinged whenever there's an update to the model. So um, definitely click on this to sign up. And yeah, we'll see you next week.
All right. See you guys next week.